Hi, Kevin Culp from Supermicro back at you. Today we're going to look at how you perform lifecycle management of compute servers inside SuperCloud Composer within a liquid-cooled data center. So you'll see some similarity where we don't do anything different in regards to performing lifecycle management. But for this particular use case, we thought we would run you through basically providing lifecycle management for physical servers. So the first thing is in a previous video we showed you within PodView how these particular AMD servers were associated with a particular rack. So they've been registered within SuperCloud Composer, been device discovered, and now they're a part of the registration process or been registered within SuperCloud Composer to perform basic lifecycle management. So we're going to click on the compute module itself, which shows essentially the hallmark of lifecycle management for a server. You'll see here on the top, nothing changes in regards to the buttons that are provided for standard lifecycle management. Things like connecting to the IKVM console, performing firmware updates, tag management, array system, UID, power management, BMC unit reset, and so on and so forth, deployment of an operating system. So let's look a little deeper at one of these AMD 4U servers. Anytime you want to perform any of the buttons on the top, you obviously would click here, and then at that point you would see here that we institute compliance and governance. This particular server is in a critical health situation, so some of the particular buttons for lifecycle management are basically grayed out for rules of engagement that we provide under SEC. Given the fact is the server's in a critical status, you would have to go ahead and mitigate or fix the server or determine exactly what the issue is before you can perform any of these tasks that are in gray. All right, so let's look at in detail the physical asset information of the server itself. So we provide the front and rear view. As mentioned, this is in a critical condition or in a critical health roll-up at this point. We could simply go and look what the critical health is of this server if we so choose by looking into the BMC log information that's provided here in the submenu log. You'll see here that we have 8 local GPUs. These 8 GPUs are H100, and we'll show you how we determine that there are 8 GPUs and how they are H100s in a few moments, but I wanted to just wait till it finishes scrolling here to show you here that in the carousel view we show you 8 local GPUs. So these are 8 GPUs that are inside the GPU server itself. And if you look at the right hand side, we provide processor information, we provide memory information. This is an AMD EPYC server for 96 total core count. It has 2 CPUs, so there would be 2 NUMA regions for each CPU. It's fully populated with Micron technology DIMMs, and you can see here it's pretty populated to indicate that we have 1152 GPUs installed for CPU 2. If we were to look at CPU 1, we would have basically the same amount of 1152 GPUs installed for CPU 1. And then you can look here at the various different part numbers, the size, the device type, serial number, so on and so forth. All right. So, and then you can look at local storage, remote storage, but let's go ahead and click on NIC information. You can see here that we provide link state for each of our AOC LAN cards. So this happens to be an AOC STGS-I2T. We provide the link state for that particular card. And then you look at GPUs here. We provide here, these are H100 GPUs at 80 GB. And we provide firmware version, part number, serial number, the number of lanes, the PCIe type, the model, and then you can collapse and uncollapse to see if you have in-ROM versions and memory manufacturer memory part number. So that is from an out-of-band perspective. We have 8 GPUs that are actually installed. And so let's look at the performance metrics of this particular server and see what kind of performance metrics we are collecting from the GPU perspective. So itself, we provide GPU performance metrics for 8 of those servers that are inside this particular rack. So each individual system has a series of GPUs. There's actually 8 of them. And you can see here that we provide a icon on the top to indicate the GPUs from GPU 1 through GPU 8. And then you find here that we're polling every 10 seconds. We can change the polling interval of collecting the metrics that we're pulling. It's a Grafana dashboard in nature where you can customize each of these. So if I wanted to move this up, I could move it up. And at that point, I could build my own particular dashboard itself. By clicking here, you have all the metrics that you can collect on the left-hand side and the different type of charting and performance statistics and chart size that you want to see. So all of this data is available to you in real time itself. And if you want to kind of look back in a look back window, we can actually go ahead and do historical trending on how well your GPU is performing. So if you had specifically this particular GPU where we're looking for unit power draw, you could edit this and you can come in and change the type of charting that you want, whether you want to perform a chart that is a gauge meter, raw data. So you can make changes or edit those once that you have them built on the dashboard. And you can look at various different levels, max, min, sum, and average. So all of those are available to you by editing the widget itself too as well. So if you wanted to quickly change the type of charting that you wanted to see, you could see it there. And then again, we show all the GPUs here for watts, as far as how much watt power is being generated or how much usage is being generated at a watt level. You can see here from GPU 0 through GPU 8. Again, the idea is by clicking here, you can see that the GPU 0 blue is in what we call the foreground and the rest are in the background itself. Okay, so we could look that for each particular individual GPU by clicking on the sidecard information for tree information. All of this is available at each particular GPU. Quickly, real-time data to see how well your performance is working or your inferencing models are working on your GPUs themselves. So let's look at alert management. So we had talked about in previous videos about the idea of alert management. We provide alert management at a BMC level, so you can see all the various different types of alerts that are being provided, such as chassis intrusion was cleared successfully. All of this data is basically harvested through Redfish message event log and session event log through Redfish subscription services, and you can quickly go ahead and search for a specific message that you're looking for. in the element list, and you can provide a starting and ending time to be able to see what type of BMCs you're looking for as far as events are concerned. And then you can see here on this CDU, we were doing some testing on a external leak sensor, indicating that sensor number 1 detected some humidity or some dew point or some water, and then we went ahead and enforced our enforcement action to shut down that server in some of our testing. You can see timestamp, and you can also click on the CDU IP address and go directly to the IP address of the CDU itself or its BMC. So we do this for both BMC and CDU as far as event logging is concerned. We'll also add in additional alert management for the liquid cooling tower. Right now, today, we have it just at a rack level, but we'll soon have all the elements for alert management for the cooling tower itself. So how would you alert on a condition as far as a leak is concerned? If you click on the admin menu and click on policies, we can do policies based on BMC itself. We have a number of trigger policies that we set at a BMC level. We continue to add to the list as far as BMC events, and then of course events that are specific to the CDU itself. We just provide today just some rack management trigger events, but we are going to be adding additional trigger events for the sensors that are related to the 30 sensors we have on the liquid tower. So we have the leak detection air, liquid leak sensor 1 and sensor 2, and you can set your policies up and then associate those policies to whatever appliances, such as the 8 servers that exist in the rack, and then you can set up recipients to acknowledge or basically send in the event that there was a leak. So those users don't have to be part of a user profile within SuperCloud Composer. They can be individuals that maybe are escalation managers that are driving your entire co-locate site or your data center, and they would be triggered based on an email address that you add in within the creation of the CDU policy. So in a nutshell, that is all we have today to talk about alert management, talk about the aspects of liquid cooling tower lifecycle management, rack management of direct to chip. We'll see you next time. Thanks for joining.